Problem, your open loop transfer function is given. We have to draw the Bode plot. Bode plot is nothing but frequency response plot, in which the magnitude versus frequency as well as phase versus frequency can be plotted. Okay, so g of s, open loop transfer function is given. G of s equal to 5 into 1 plus 2 s divided by 1 plus 4s into 1 plus 0.25 s. Okay, so first step is you have to convert this into a Bode form. Okay, so how will you convert this open transfer function into Bode form? You have to substitute s equal to j omega. Okay, so substitute s equal to j omega in g of s. It will become as, you will get as g of j omega is equal to 5 into 1 plus 2 j omega divided by 1 plus 4 j omega into 1 plus 0.25 j omega. So this is a Bode form for the above g of s. Next step is magnitude plot. So for magnitude plot, we have to find the gain for different frequency. Okay, we have to find the gain for different frequency. Okay, so first in magnitude plot we have to find the corner frequency. Corner frequencies are nothing but the frequency at which the magnitude or slope change occurs. Okay, so corner frequency, how will you find out the corner frequency? By taking the coefficient. Okay, so the coefficient of j omega, in these terms we have a, 1 plus 2 j omega in the numerator and 1 plus 4 j omega and 1 plus 0.25 j omega in the denominator, and you have to see the coefficient of j omega. Coefficient of j omega is 4, coefficient of j omega for this is 0.25, and coefficient of j omega is 2. Okay, so you have the formula for corner frequency is omega c1 is equal to 1 by t. So t is nothing but the coefficient of j omega. Okay, omega c2 is equal to 1 by t2, omega c3 is equal to 1 by t3. The corner frequencies, the formula is 1 by t. So t is nothing but the coefficient of j is t. So this is t. Okay, the coefficient of j omega. So the least one is omega c1. So okay, 1 by 4, 1 by 4, 1 by 4 is 0.25, and 1 by 2 is 0.5 radian per second, and 1 by 0.25 is 4. Okay, we have to order in such a way that the corner frequency has to be ordered like from lower to higher. Okay, so lower is a omega c1, and next to higher is 0.5 is omega c2, and next to higher is 4 is omega c3. Okay, so in this table we have to draw a table. In this we have to list out the corresponding corner frequency and the slope and the change in slope from one term to another term. We have to list out all those things. Okay, so first term should be either k or k by j omega or k to j omega. Okay, so we have a k, right? So there is a constant value is there. That is our first term. You have to split this into terms like this. Okay, you can write this in terms of like terms, different terms. 1 by 2 j omega divided by 1 plus 4 j omega into 1 plus 0.2 j. Each term is called a factor. Okay, each term in this equation is known as factor. So the factors are either constant, or it may be a 1 plus j omega term in our numerator, or 1 plus j omega in the numerator. Okay, denominator. So in this first term you should take as a constant, either k or k into j omega or k by j omega. So here k is there, that is 5. For 5 there is no corner frequency, there is no slope difference. Okay, it is 0. So there is no change in slope because it is the initial one. So for the next is second term you have to take from this order. Okay, so that the least corner frequency, which term has the least corner frequency, that term has to be taken. Okay, so least corner frequency is 0.25. so 0.25 is come from this term. Okay, so 1 by 0. So this term has to be taken as a first term, second term, 1 by 1 plus 4 j omega, and its corresponding corner frequency is 0.25. Okay, and its slope is, see, j omega is in the numerator. Okay, so denominator, so you have to write the slope difference is minus 20 decibel. Okay, so there is a slope change in slope from previous term to next term. Okay, so it is 0 minus 20 is minus 20 decibel. Okay, so this is a change in slope. We have to add these two. Okay, so next term corresponding to the next corner frequency 0.5 radian per second. So that is this term. So 1 plus 2 j omega and its corresponding corner frequency is 5, sorry 0.5. So the j omega term is in the numerator, so it is the slope for that term is plus 20, okay, plus 20. So if you add these two, if you add these two, you will get 0, okay, 0. So next step is 1 by 1 plus 0.25 j omega. So the corner frequency is 4 and the corresponding slope difference is minus 20 decibel because the j omega term is in the new denominator. Okay, so the change in slope is 0 minus 20 decibel is minus 20 decibel.